Okay, here we go, vector algebra. First thing I'd really like to do is just some simple terminology. It's really important that we're talking the same language, that when I use words you understand them to mean what I think you understand them to mean. So we're going to begin with some basic definitions. The first one is magnitude, which is just a word we use for size. So we can talk about the size of something, we can say the magnitude of something. So for example, we can talk about mass having a size of 5 kilograms. And in the language we're going to use here, we're talking about the magnitude of the mass being 5 kilograms. Notice that it does have a unit associated with it usually. A quantity which only has magnitude is what we call a scalar. So mass is a scalar quantity. We just talk about the size of it. The mass of this bag of potatoes is 10 kilograms. We don't have to give it any other information. We have to say whether it's 10 kilograms up or down, or left or right, or blue or green, or anything. Just simply the size is all we need, the magnitude. We can also talk about direction, which really is used by the very technical term direction, which says it all. So when we talk about our bag of potatoes, if we talk about weight rather than mass, we talk about the potatoes having a weight of maybe 100 newtons, and we'd say it's acting downwards. So we have both a magnitude and a direction. And any quantity which has both a magnitude and a direction is what we refer to as a vector quantity. So weight is a vector quantity. We talk about the weight of something being 100 newtons downwards, whereas mass is a scalar quantity. We just talk about it having a mass of 10 kilograms. Not only do we need to be able to speak the same language, we need to be able to write the same language. So notation is important as well. We need to be able to write stuff that we all understand means the same things. So if we want to write something as a vector quantity as opposed to a scalar quantity, we need to use a different typeset. Basically, a scalar quantity can be any type of your plain text we use for scalars, whereas vectors we tend to use any other type of font. So we can have it as a bold, or as an underline, or as an italic. Each of those would be appropriate for a vector quantity. Magnitude, we're going to denote by these straight lines on the outside of it, which you may have seen for absolute value, but it just means size. So here we'd say the magnitude of P is straight lines of P, and we'd read it as the magnitude of P. If something has a magnitude of 1, then we talk about it being a unit. So any particular vector with a magnitude of 1 is a unit vector. Nice and simple, 1 being unit. Okay, once we've got that sorted, then we can start talking about our coordinate axis. You're familiar with axes being traditionally in 2 dimensions, the x-axis and the y-axis, which form the Cartesian plane, named after René Descartes. He's an interesting character if you ever want to read about him. But for this course, we're going to be wanting to deal with 3-dimensional space. So we need to be able to put a third axis into it. So not only are we going to have the x-axis and the y-axis, we're also going to have the z-axis. And the key thing here is that each of these axes are at right angles to each other. So there's a 90-degree angle between the x and the y-axis, and a 90-degree angle from each of the x and the y-axis to the z-axis. Okay, it's an important note, this is what we call a right-hand system, which means that if you go from the x-axis to the y-axis in this orientation, then the z-axis has to be pointing up. It's called the right hand because if you take your fingers of your right hand and move them from the x-axis to the y-axis, your thumb will be pointing up the z-axis. It's also possible to define this in terms of a set of vectors. So if I just imagine I have 3 unit vectors, so magnitude of I equals the magnitude of j equals the magnitude of k equals 1, and they're each at right angles, so my I vector is on my x-axis, my j vector is on my y-axis, and my k vector is on my z-axis, then these 3 vectors form what is called a basis for the space. I can use them to point in any direction I want to. Don't worry about the size, we'll come to that shortly, how you can scale them to get different distances, but the direction I can make in any combination of these x, y and z axis, or the I, j and k vectors. Combinations of those I can use to point to any point, so they cover the space. And I have a set of vectors which I can use to indicate any point in the space, and I'll use those to do all sorts of interesting things within the space and talk about scaling them in the next section.